This is Robert Sapolsky, and you're listening to Father-Offspring Interviews.
Hi, welcome back to Father-Offspring Interviews, episode 70. For our first question, Musen from California asks, what is currently known about the placebo effect? Is there an inverse placebo effect where an effective medication loses efficacy if the individual believes it is a placebo?
Placebo effect. Placebo effect, it is for real some of the time. It could be quite substantial some of the time. Placebo effect. You have somebody, and instead of giving them an active medication, you give them a placebo, a sugar pill, without telling them that you are doing that. And what the placebo effect is that often the person will respond to the sugar pill as if it was the actual medication. Oh, actual medication to keep you from rejecting your heart transplant. Placebos don't do much there. They're most effective in the realm of pain. So you give somebody a pill which they believe is a painkiller, and it's actually a sugar pill. And in a significant subset of individuals, pain ratings go down. And as we'll also see, other versions of placebo effects, therapeutic methods, types of surgeries, but predominantly giving somebody a fake medication. So what you see is these effects can be quite dramatic, and sometimes they could be extremely difficult to demonstrate, lots and lots of variability there. So what begins to explain the variability? People have done all sorts of studies looking at demography. Are people of certain ages, of certain sexes, of certain backgrounds, of certain number of cavities, whatever, are there predictors there as to who's going to respond strongly to a placebo and who won't? And that doesn't tell you much. What are some of the things that comes out of it? If you were anxious at the time, placebo effects don't work very well. If you were feeling calm, if you were feeling comfortable in your setting, if in this medical setting you feel as if you have been being treated well, you've liked the quality of your medical care, when the person says, here, take this pill, it can be quite effective there. And in that circumstance, you were much more likely to report that, yes, your pain has gone down. What else? The wording counts. The person who is handing this to you, the health professional, if they say, here, have this pill, it's quite effective at decreasing pain in most people, versus, here, take this pill, it often decreases pain. The latter, you don't get as much of a placebo effect. The biggest contributing factor in terms of whether or not someone's going to have a placebo effect is if they think they're going to beforehand, their expectation. If you ask people just before they take the sugar pill, how effective do you think this is going to be? And if they say, yeah, the doc says this is going to work really well, more expectation, more efficacy. Okay, so that's great. There's problems, though, confounds that come into doing this. First off, obviously, these are blinded subjects, as in, you don't tell them, here, I'm giving you a sugar pill. The subjects don't know if they're getting the real medication or the placebo. They don't know. But where a problem comes in is if the medical professional administering the pill knows which it is, because tone of voice, something's going to creep in. If you're like a grad student and you're getting your degree, counts on being able to show the placebo effect, and you're handing out this pill, sometimes the real pill and sometimes the placebo. When you're handing out the placebo to your subjects, you're sure going to say, here, people have found that this is really, really good at decreasing pain. You got to have it double blinded. The person handing out the pill can't know if it's for real or not, because they can be unconsciously cueing the person as to what's happening. So that's a confound that has to be worked out. So gold standard is you've got three arms to the experiment: people who get no treatment, people who get the actual medication, people who get the placebo instead of the medication, and it's done double blind. There's another interesting confound that creeps in, though. which is if you're dealing with somebody with a chronic pain syndrome, they've taken a lot of these painkillers over time, and they have a pretty good sense of what the side effects are going to be like. And thus, they take the placebo, and very often they're able to say, you know what? I don't think this is really the medicine because I'm not getting the side effects. This has required level placebo 2.0, what they now call active placebos. You have to take your sugar pill and put some medications in it that will cause the side effects. They just won't cause the primary thing you'd be taking the medicine for, so that the subject is feeling the side effects, but it's a placebo. So that's showing how sophisticated this can be. One interesting thing showing how a placebo effect is infiltrating, even when there isn't a placebo being used, which is people who are highly, highly responsive to placebo effects are also people who are more responsive to the medication itself as a painkiller. What does that tell you? Whether they're being given a placebo or an actual painkiller, expectation that it's going to work is playing a role in the pain perception. Okay, so that's the world of placebos where you're giving somebody medication. Then there's the highfalutin placebo experiment world of things like neurostimulation. An electrode is transplanted into somebody with Parkinson's disease to try to stimulate some more motoric control, things of that sort that could be done. And the placebo version is you implant the electrode, but you don't stimulate it. Huh. Or a placebo study of a surgical procedure. You knock the person out and you cut them open and sew them back up, but you don't do anything inside. Whoa, these are quite different from giving somebody a sugar pill. And immediately you got a couple of problems that arise there. First off, is an ethics one. Like, wait, you're going to do brain surgery on someone to put an electrode in there, and you're not really going to attach it and see if that works. You can get a nice paper published and get your degree. It's very problematic. What people tend to really look for are the surgical placebo studies, ones that are laparoscopic, where it's a tiny incision, where they then lead in like a fiber optics camera thing, and you'll have a stitch or two afterward. That's where it's done most often. The other problem or challenge with surgical placebo studies is the surgeon can't be double blinded. The surgeon knows whether they're actually doing the surgery or not. So that infiltrates the whole thing as well. One interesting thing with it, which is a number of studies on surgical placebos that are done with local anesthetic. And the problem there is the person is awake. So you've got to have the area you're doing whatever to covered up, and you've got to mimic the correct sounds and the right smell of their muscle being soldered or whatever it is you're doing so that it's convincing. All sorts of controls have to go into it there. So, of course, at this point, we got to ask when a placebo effect is working. And again, highly variable from one person to the next, highly variable within the same person as to when a placebo will or will not work. A lot of variability. What's going on when it is working? So, brain imaging. Functional MRI study, stick somebody in a brain scanner who you're about to induce a placebo effect in, or see if you can induce it. And you've got two different pictures to pay attention to. What's going on in their brain when you've told them, I am about to give you this medication, which we've found is a pretty effective painkiller during the period of expectation. What activation do you see in the brain? Part of the brain that we've heard about plenty, the anterior cingulate cortex, which has a lot of the interpretation that we give to pain. In other words, your brain is gearing up to decide whatever it is I'm going to swallow, things are going to feel less painful afterward if you have high expectations. A part of the brain, totally obscure for us, called the periaqueductal gray, which has a lot to do with pain transmission from the spinal cord up to the rest of the brain. It tends to be inhibited there. So, this is the picture in anticipation of. Once the person has taken the placebo and they now believe they've just taken this effective drug, where do you see activation in the brain? Once again, the anterior cingulate, how to interpret what you're feeling. And what the anterior cingulate is doing is biasing you to interpret the pain as not quite as painful as it was before. And very interestingly, also activation in the form of decreasing excitivity in what's called the somatosensory cortex, the part of your brain that's feeling, ooh, this elbow hurts, this big toe hurts, that's responding to the pain in a very localized manner. Those are the areas. In other words, when you are taking a placebo and it is working in you, your brain is telling the part of your brain that is responding to painful stimuli that they're not really so painful. So don't respond. What's going on with the neurochemistry of it? And for the most part, the clearest thing that's been implicated in placebo effects are opioids, not opioids epidemic, opioids, endogenous opioids. Opioids, synthetic drugs or naturally occurring drugs which you take and block pain by binding to opioid receptors. And people eventually realized, well, we did not evolve opioid receptors 100 million years ago because someday somebody is going to invent some sort of opioid drug. We have endogenous opioids in our bodies. Endorphins, for example, are of that class. We have endogenous opioids. And what appears to be the case is when your expectation is going just right that this pill you're about to swallow is going to decrease pain, you were secreting your endogenous opioids. Clearest demonstration of this. This was sort of what started the whole neurochemistry of placebo effects. 1978, give people a drug that blocks opioid receptors, a drug called naloxone, which is often used now to reverse opioid overdoses, blocks somebody's opioid receptors, and placebos don't work anymore. In other words, it's being mediated by, ooh, this pill is really going to work. I've just been told that by somebody I trust. I'm expecting this, and you secrete opioids and it binds to opioid receptors, and that brings about some of these brain changes. Years since then, what people are realizing, there's also a role played by endogenous cannabinoids. Same deal here with pot, with THC, with endogenous equivalents of these same compounds, which will bind to cannabinoid receptors, and they seem to have some role in placebo effects. Dopamine seems to play a role also, and an interesting genetic piece comes in that there's one enzyme that breaks down dopamine, and it turns out different variants of that enzyme's gene is associated with more or less responsiveness to placebo effects. Oxytocin, people who are more responsive to placebos tend to have more oxytocin in their bloodstream, vasopressin. Okay, so there's a neurochemistry. It's making sense. So we get here to three wrinkles at the end. As posed in the question, can you get sort of an inverse placebo? Somebody is so aware that sometimes those healthcare professionals will sneak you a placebo that you give them the actual drug and they're convinced it's a placebo and they report no effect. Yeah, this can happen at times. This is not well studied. What's also demonstrated, but not terribly well studied, is what are called nocebo effects. You give somebody a placebo and they insist they're feeling all sorts of side effects. They're feeling terror, they're feeling queasy, and they're feeling dizzy. And they're not just attributing pain lessening effects to the sugar pills, they're attributing side effects to them as well. The final one is I've seen one study showing this, and it's totally charming. You take people and you give them a placebo and you tell them it's a placebo. You say, here's a sugar pill. It's a placebo. And we're giving you this because often placebo effects can be quite powerful. And if the person is sophisticated and understands that placebo effects can be for real, it works because they know that placebos are effective. In other words, if you get someone who understands that sometimes the expectation that this is going to work could actually blunt pain, this person's expectation that the expectation is going to blunt pain can kick in. So that's like placebo 2.0 in terms of subtlety. And you, Rachel, showed a wonderful placebo effect when you were about 4 years old. You had an ear infection. We took you to your saintly pediatrician, Dr. Ernster, who we love, and he examined your ears and, in fact, ultimately concluded that you did have an ear infection and gave you some antibiotics. But after he looked in your ear, your first ear, looking in there as he stepped away, you said, "Wow, I feel so much better now." Great placebo effect.
So now, Chester from New Zealand says, your highly viewed human behavioral biology lecture series on YouTube is 14 years old now, and I'm wondering if there's anything in those lectures that you would consider to be significantly outdated information?
Oh, in case you're wondering, Chester is not our cousin in New Zealand who we planted this question with, but the timing is spectacular for it. Every year, I teach a class at Stanford called Human Behavioral Biology. And 14, 15 years ago, Stanford taped one of them and posted the entire course, and it's been up on YouTube ever since and has gotten a lot of views. And nonetheless, exactly as contained in the question, the science is not completely up to date now, and the course has been changing each year. So I taught the course last spring, filmed it again, and we are about 3 weeks away from posting it on YouTube. We will put up a URL for how to find it.
Finally, John from New York says, given that tit for tat is the best strategy in game theory, why is Israel's response to Palestine not exactly that?
This is going to be a lengthy answer getting to a remarkably simple conclusion. All right, to state something perfectly obvious, cooperation is a good thing. When people cooperate, many hands make the task light. When wild dogs hunt cooperatively, they have a much higher success rate. And forever, evolutionary biologists have been struggling with this issue of, if no one has invented cooperation yet in your species, how do you get it started? Because if no one's cooperating, the first individual who says, "Aha, I've read all about the evolution of cooperation and I understand the common good. And so I am going to do something self sacrificial for everybody else's benefit." And everyone else is going to say, "Oh my God, what a schmuck. I can't believe he did that," and take advantage of them. So, one huge challenge is, how do you jumpstart cooperation in a population where cooperation is not there in the first place? And there's some very interesting models for that, and that's a whole fascinating field. Once cooperation begins, you have social organisms cooperating with each other. There's the next challenge, which is, you can cooperate or you can cheat. You could take advantage of the other individual. And when they cooperate with you, you don't cooperate back. You could stab them in the back. And thus, out of that has come this massive question in evolutionary biology. How do different organisms evolve their strategies for when you cooperate, when you cheat? Now, throughout the fruit fly, the poster child of people studying this has been a game theory game called the Prisoner's Dilemma. And this was an interesting point where ethologists, evolutionary biologists started borrowing game theory from political scientists, economists, military strategists, folks like those. And everybody focuses in inevitably first on prisoner's dilemma. Here's the scenario: you've got two people cooperating to carry out a crime. They both get arrested. They're taken into separate rooms for questioning. And in each room, the person says to them, "All you have to do is say you did it, and say your buddy there did it even more. And you're going to get off pretty easy here." And they're going to get a gigantic. While at the same time, in the other room, they're saying to them, "All you have to do is finger your buddy here," and they're going to get blasted with a long sentence. And you're going to get off light. So there's four possible outcomes there. Both individuals refuse to stab their partner in the back. Neither of them rat on the other, and they both get a moderate jail sentence. The first one is cooperative, doesn't rat on his partner, but his partner stabs him in the back and rats on him. And what you see is the person who cheated gets off easy, and this person gets a huge punishment. In other words, they're the sucker who's been cheated against. Third scenario, same exact thing, but in the opposite direction. Cooperate, cheat. The cheater gets a big advantage. Fourth scenario, they both rat out each other, in which case they both get a middle level punishment. So the question becomes, when does cooperation pay off? When does cheating pay off? What's the optimal strategy? And this brought up this famous study from this political scientist at University of Michigan named Robert Axelrod, who collaborated with this evolutionary biologist named W.D. Hamilton, Bill Hamilton, who's one of the gods of the field. And they did this collaborative study. This was, I don't know, in the 70s, 80s. It was somewhere in the ancient past. So they got some ancient primitive computer and programmed it to be able to play rounds of the prisoner's dilemma. And they wrote to all of their friends, their economist friends, their political science friends, their biology friends, their mathematicians, their Nobel Peace Prize winners, their professional boxers, their murderers for hire, wrote to all of them and said, here's how the prisoner's dilemma works. What would be your strategy? Tell me what your strategy would be. And they got strategies back from everyone. And of course, some of them were very ornate and probabilistic. And if the other person does this, you do this percentage of the time. But if they do this within the next 3 moves, then you do this, like hugely complicated strategies. And the whole idea was each of these strategies they got back, they then programmed and ran a massive round robin tournament on the computer of pitting the different strategies against each other. And the famous finding from this was one strategy outcompeted all the rest. That's cool. Even more interesting, it was the simplest strategy you could possibly use, what is now called tit for tat. In the very first round, the person you're playing against, in the very first round, you start off by cooperating. If they cooperate in that round as well, you cooperate in the next round and they'll do the same and you keep going. However, if from out of nowhere, one of those rounds, they stab you in the back, they cheat when you've cooperated, the next round, you cheat back. You do a tit for tat. At that point, if they say, ooh, I guess I'm not getting away with this, and they go back to cooperating, you go back to cooperating, and it's all sorted out. Tit for tat outcompeted all these other strategies. And to show that these were evolutionary biologists thinking about this, they began to talk about tit for tat would drive all the other strategies into extinction. Why was it so effective? Had four things going for it. First off, it was simple. It was not this complex probabilistic algorithm thing that all the mathematicians were sending in. It's very easy to understand. Next advantage, your starting point is an assumption of cooperation. You cooperate in the very first round. Third advantage, it's punitive. Somebody stabs you in the back and you punish them. Fourth, you were then willing to forgive them and put all these pieces together, and it beats all the other strategies. As I said, in one particular round, you may fall behind because they stabbed you in the back first. As I said, in the field, tit for tat, you may lose the battles, but you will win the wars. So people looked at this and this was so exciting that this was the optimal pattern. And in the years since, people have shown in what circumstances tit for tat can evolve into something more subtle. And there's cycles of this totally interesting stuff. And at that point, ethologists, people who studied animals out in the wild, went crazy running out there because everyone had read Axelrod and Hamilton, famous, massive, go and see if there's any animals out there who actually have their cooperative social systems working on tit for tat. Your starting point is cooperation. If your partner cooperates, you continue doing it. If they stab you in the back, the next time you stab them in the back, and all sorts of evidence for that coming in, that animals out in the natural world have evolved tit for tat systems that optimize cooperation while protecting you from cheaters. Totally cool. So in humans, there turned out to be an astonishingly fascinating, moving historical example of tit for tat being a means for cooperating to emerge under the most inauspicious circumstances humans can come up with. World War I, trench warfare in France, predominantly British troops facing German troops across the trenches. And everyone knows the nightmare stories about how appalling that was. Lots of people will know one of the great sort of events in history during that, which was the Christmas truce of 1914, the first winter of World War I, and heads of state and popes and all of them said, tell you what, let's have a truce for Christmas evening and let's tell all of our soldiers to stop shooting so they can enjoy Christmas dinner. And very famously, people came out of the trenches and people from the opposite side shared dinner and they exchanged presents. And the next day, they continued the truce. They played soccer out there with each other. They exchanged addresses for. Okay, so that was the Christmas truce. That was not an example of tit for tat emergent cooperation because that was a top down. Presidents and kings and kaisers and popes all agreed we're going to do this. Throughout World War I, there was another example of spontaneous truces that emerged that showed the tit for tat strategy. And this was work that was documented, a British historian, Tony Ashforth, who has shown how this evolved, the live and let live system in the trenches in World War I. Okay, so first off, you and the enemy 100 yards away on that side, you begin to tacitly have a truce under some circumstances. And this is not by commission, it's by omission. You suddenly notice they don't shell you during dinner. So you stop shelling them during dinner because everybody wants to have dinner. What a drag it is to sit down and have dinner and instead you're killed. People would stop shelling each other during dinner. People wouldn't shell the latrines on the other sides. Who wants to get blown up when in that sort of setting? When a wagon train would come in with supplies and food, the other side typically would not shell the wagon train. Why? Because of punishment coming back, a shadow of the future. They're going to blow up your food trains when they arrive. So there was this backdrop of soldiers tended not to shell each other during meals. When someone was in the bathroom, they didn't blow up the latrine. And when supply sort of lorries were coming in, they're bringing in food for everyone. So what has that done? You've now established the person on the other side, those guys in the distant trenches there, they're rational, they're reasonable, we can work with them. And a key component of this was the same troops were opposite each other for weeks or months on end, and the soldiers were beginning to know each other's calls. The Brits would wake up in the morning and yell to the Germans. What did they call them in World War I? Did they call them Jerry? They say, Guten Tag, Jerry, and Jerry would yell back and they would yell playfully offensive things about each other's royalty. And you were now establishing they're reasonable. We can work with them. And that's where you begin to actively, by commission, begin to form a system of cooperation, of mutual restraint, of a truce that wound up following a tit for tat system. How do you do it? You get your best gunner, and there's some old bombed out barn just behind the front lines over on their side. And your best gunner there puts a bullet into the wall there of this barn and then shoots again and hits the exact same spot and hits that spot 20 times in a row. What are you communicating to the other side? Look how good our guy is. He could have been shooting that accurately at you. He chose not to. We told him not to. He didn't have to do, he chose not to. What are you going to do about it? And then the other side would get their best gunner who would go do the same thing. And you've just worked out a system of protecting each other, not shooting at each other. And over, this evolved up and down the lines in the trenches there. They figured out ways to shoot over each other's heads. They figured out ways to signal to the other side when the officers were coming. So, sorry, we're going to have to shoot for real for a while. And when the officers left, they got their best gunner again, who would put 10 bullets into the same hole. They would respond, and okay, we've gone back to our truce. And in this book that Ashforth wrote about this, he documents soldiers sending letters home to their parents saying, I'm okay here. You know, the guy in the other trenches there, they're not so bad. They're kind of reasonable folks. And we've worked out something. Nobody's getting hurt much. We're okay. So they worked out these truces over and over again, and over. Officers eventually got word of this, showed up, had to threaten to court martial or shoot people to get them back to actually shooting, or transfer troops up and down so you didn't know these people. But over and over, this happened. So, where did tit for tat come in? If there was occasionally an error made, what would be the error? The classic thing, you've got some new artillery gunner guy who's brand new and gung ho, and he doesn't know how things work yet. He doesn't know about this true stuff, and he's still gung ho about for God and country, and lands a shell into their trench and kills a few guys. You say, idiot, we don't do that. We got this thing worked out. You don't do that. And at that point, you send somebody up above the trenches and you yell over to the other side and you say, sorry, we've got this new guy here. He's got his head up as he doesn't understand. Sorry, we got him under control. But then, just to show that this was a tit for tat system, those guys would now lob one or two shells into your trenches and kill a few of your guys. And then you would go back to the truce. And this was established over and over, and they got something close to tit for tat. It apparently, depending on which front, it varied whether they got to shoot back once or sent back two shells for each one you sent over there by accident. But this was a tit for tat system. People worked this out without exchanging a word, without even speaking the same language, while being ostensibly sworn enemies in this bloodbath. They were able to work this out there. All right, so all of this brings us to the question here, why isn't Israel using a tit for tat strategy in its war on Palestine and its war on Hamas and its war on Gaza? And there's a very simple answer to that. October 7th, Hamas attacked Israel, barbarically slaughtering 1,200 people there. And all one needs to consider is that was not the first round of that prisoner's dilemma game. That game had been going on for decades with very, very unequal sides. But in any case, that happened and looked at in historical isolation, which is really a tough thing to do and often inadvisable, but just looked as if that were the first round in a prisoner's dilemma game. And from what we just learned about tit for tat stuff, Israel is now supposed to bomb them, kill a couple of thousand Hamas. And as we know, instead, what has happened is that ever since then, Israel has been turning Gaza into a land of the dead and has displaced most of the population, has destroyed most of the habitable buildings, and has killed a ghastly, unbelievable number of civilians, including old people and children. Earth's highest concentration of kids with amputated limbs can now be found in Gaza. As of last June, a paper in The Lancet, which is about as much of a mainline dead white male medical journal as you could get, at that point, putting the number of deaths in Gaza between 60 and 70,000. And it's been more than a year since then. And the number has gone way above that. So the question then becomes, wait, we just saw that, tit for tat. If you want to reestablish cooperation, you don't have a disproportionate response. Why go kill 1 to 2 orders of magnitude more people? And the answer is very simple. Tit for tat, prisoner's dilemma, all of that is about how to establish and maintain cooperation. And the obvious punchline here is Israel is not interested in cooperation.
And that is episode 70. I'm Offspring Sapolsky, and thanks for your continued support of science and the beard.